Hello and welcome to today's chat. We're going to talk about the planet Mercury as part of our discussion of the inner planets. And a lot of what we're going to do is compare and contrast what we saw with the Earth. We'll take an overview, seeing where Mercury is in the sky, its orbit, the lack of atmosphere, talk a little bit about its surface, although it looks a lot like the Moon. There's a big difference between Mercury's interior and the Moon. And finally, we'll talk about different missions to Mercury so far. So in any case, Mercury, just a general overview of the planet. It's obviously the closest to the Sun. It's the smallest of the 8 major planets. And I have to, of course, remind you that Pluto is no longer considered to be a planet. So when we're talking about the 8 planets, we're talking about the 8 inner planets. I'm sorry, the 4 inner planets and the 4 outer planets. It can only be viewed early in the morning or late in the evening. And in fact, Mercury is the most difficult of the 5 planets visible to the naked eye to see, because conditions just have to be absolutely superb. Mercury has to be as far from the Sun in the sky as possible. And because it orbits well within our orbit, it never strays very far. What else about Mercury? It does have a very small mass. It's the least massive of all the planets, but it's actually the highest density if you take away gravitational compression. Its orbit is highly inclined, which means that it makes a pretty good angle with respect to the plane of the solar system. Its orbit's pretty elliptical. It's pretty eccentric. Again, much like the Moon, it's highly cratered, and its surface is very, very old. There's no significant atmosphere to Mercury, and that's because it's very close to the Sun, and also because it's not very massive. So in any case, comparing Mercury to Earth, if we place them side by side, is what they look like. And Mercury's radius is a little more than a third of the Earth's radius, but it only has about 5.5% of the Earth's mass. That's basically saying that Mercury is about 18 times smaller in mass than the Earth. Compared to the Moon, Mercury is bigger. It's 40% larger in radius and significantly larger in mass. Now, because Mercury has a similar density to the Earth, and we take into account the radius, both its volume and its mass have the same ratio with respect to the Earth. They're both about an 18th the amount. In any case, looking at a comparison of the inner planets, clearly Mercury is much less massive than Mars. Mars is about twice as massive, and it's significantly less massive than Venus and the Earth. So really, Mercury is the smallest of the inner planets. Looking at its orbit not only is closest to the Sun, it's about a third of the way closer to the Sun than we are. It receives, at that distance, about 6.5 times as much sunlight as the Earth does. It only takes 88 days to go around the Sun. The interesting thing is it actually rotates every 59 days. So it actually rotates 3 times for every 2 orbits. And this is not a coincidence. This is gravitational locking that takes place. And it's due to energy considerations that the densest part of Mercury always points toward the Sun every 2 orbits. So, the highly eccentric orbit, it has an eccentricity of 0.20. That just means that it's the most oval of all the orbits. And also because of its close proximity to the Sun, its orbit, the oval, remember, all the planets go around the Sun in elliptical orbits. The oval actually rotates around the Sun with time. Now, the interesting thing is, in 1915, Einstein published his theory of general relativity. He showed that time actually slows down in an intense gravitational field. Now, the Sun is the most gravitationally intense object in our solar system. So Mercury, being very close to it, actually feels a slight slowing of time due to that. And this causes the precession to be different than it would be if it were just due to gravity according to Newton's laws. So Mercury's precession, the rotation of the ellipse around the planet, actually is a confirmation of Einstein's general theory of relativity. Well, in any case, so what do we know? Mercury's orbit is very oval. It's actually quite inclined, makes a pretty good angle with respect to the sun. But the axis of rotation is actually perpendicular to the sunlight. So the strange thing is that both the North and South Pole, some of the craters never see any sunlight. And we'll talk a little bit about that later on. Now, the solar system's been around for about 4.5 billion years. The interesting thing is Mercury's orbit of all the planets is the least stable. And, that's generally due to the fact that it's small in size, so it doesn't have a lot of inertia. But it's also close to the sun and close to a lot of the inner planets. It interacts with the inner planets. So its orbit actually fluctuates as a function of time. And if its eccentricity, the oval shape of its orbit, which is constantly changed by the planets, if it ever went beyond 0.6, it would cross Venus's orbit, causing the two planets to interact. And most likely, Mercury would be sent flying either toward the sun or away from the solar system. Now, again, our solar system's been okay for about 5 billion years. But if, things lined up and computer simulations show that there is a small chance that this could happen, even though it's rather remote, Mercury would be probably flung into the sun by an interaction with Venus and be vaporized. Of course, the worst case scenario is very, very low in probability, but there is a slight chance that Mercury could interact with Venus, and then it could be sent our way. And if that happened, it basically vaporized the surface of our planet. Now, again, this is such a low probability event that we really don't have to worry about it. But it is still, possible that someday Mercury may not be in its current position. Well, even if Mercury survives, there will come a point in about 5 billion years where the sun will expand to become a red giant. When this happens, the surface of the sun will engulf Mercury, and Mercury will slowly sink to the center of the sun as it vaporizes. So in any case, Mercury is a doomed planet. It, orbits very close to the sun, and because of this, it's the most likely of all the planets to eventually get consumed by the sun, either by interacting with other planets like Venus, or as the sun gets old and it expands, the surface of the sun would eventually exist. Yes, there are a few atoms that are blown off the surface, but Mercury has no significant atmosphere. It's just like our moon. There are a few atoms that are sputtered off the surface of the moon to create a very tenuous collection of atoms, but it's just too small and too hot for atmospheric gases to remain bound. It may have been that when Mercury formed, gases initially were given off by different volcanic activity. But essentially, the only thing that we have for an atmosphere today is something called an exosphere. It's a very, very low density collection of primarily sodium atoms, which are sputtered off the surface. Radiation from the sun will break these sodium atoms free, and they'll basically stick around the planet before drifting off into space. Now, we assume that Mercury formed just the same way as all the other inner planets. It formed from the bombardment of different planetesimals, the accretion of different material, and the lighter materials in these planetesimals were released as volatiles, as gases. And basically, these gases around the larger planets like Venus, Earth, and Mars were able to stick around because the gravitational fields were strong enough and the temperature wasn't high enough. But again, for Mercury, even as the gases would leak out into space, again due to volcanism or other processes, essentially the gravity just wasn't strong enough to hold on to them, and the solar wind would heat up any gases that would collect. I mean, we can understand some of this basically through something called the Maxwell-Boltzmann distribution. If we graph the speed of molecules as a function of temperature, we see that in this first graph, when the temperatures are low, the speed of the molecules also remains low. Okay? They don't have enough speed to escape the gravitational field. As an atmosphere gets hotter, however, more and more of the gas gets higher and higher velocities. And in the case of Mercury, the gas gets so hot that it reaches the escape velocity of the planet, which is not all that hot for Mercury, and the atmosphere just leaks into space. So again, with Mercury, basically what we have surrounding it are a few, let me get to the right slide here. We have, sodium atoms, a few other atoms, which are sputtered off the surface. And you can see in this diagram right here, most of the atoms that are in this atmosphere collect on the sunward side and then produce this long tail as the atoms drift off into space. So, essentially, for our discussion, Mercury has no atmosphere. Again, why? Mercury's too close to the sun, it gets too hot, and also because Mercury doesn't have enough gravitational field to hold on to it. Now, looking at the surface of Mercury, because there's no atmosphere, there's not going to be any weathering due to rain or wind. So the surface is pretty much the way it has been for billions of years. It's very old. There are many craters. Most of what we see on the surface are impacts that happened around the time of the Great Bombardment. Probably about 3.5 billion years ago. And again, we just look all over the surface, lots of craters, and just about everything in the solar system that has a solid surface can be aged, or we can determine the age by counting the craters. And when we look at Mercury, there are just so many craters. It really tells us that we're looking far back in time when we're looking at when the surface was being formed. One interesting feature on the surface is barely visible. It's called caloric basin. And this feature can only be seen, really, when we computer enhance different photographs. In this particular case, we can see, I'm not going to do a great job drawing this oval, but we can see sort of this oval structure. It makes more of an angle, where the rock has less blue than the surrounding rock. And again, this is taken from a photograph from the Messenger space probe. And by enhancing the different colors, we can create this contrast. Well, caloric basin is huge. It's basically ringed by um, these mountains. It was formed by a large planetesimal, a large asteroid-like body that slammed into Mercury. And because the crater was so large, it almost immediately filled with magma. And essentially, a basin was created, but you know, because of its size, it's pretty much flat. Now, the impact itself, um, again, was almost almost had enough energy to blow the planet apart. It created huge seismic waves, huge earthquakes, and these earthquakes traveled through the planet and were so severe that they were focused by the core of the planet and ended up breaking up the surface on the opposite side. So really, um, something that energetic, something that big, to produce this large porous basin had to be a violent event. Here's another large impact basin. Its name is Rembrandt. It's not quite as large, but again, here's another large impact basin, and this one's a little bit easier to see. Again, it's ringed by mountains. This is actually two photographs merged together. But these large impact basins are very similar to what we see on the moon. On the moon, we had these big maria, these big impact basins that were filled with basalt. Rembrandt and Course Basin are the equivalent on Mercury. One interesting feature that we see on the planet are these lobate scarps. Lobate scarps are fractures in the surface that occurred most likely when Mercury's core began to cool and the outside of the planet, what we call the lithosphere, which includes the crust and part of the mantle, had already solidified, so they're no longer pliable. Well, it's more or less like when you dry a plum to make a prune. Okay? The surface, the skin, has the same surface area. That doesn't decrease. But the center of it, as it dehydrates, or in the case of Mercury, it's actually cooling down, it'll thermally contract, decreases in volume, and this creates wrinkles. And, you know, on the prune, or when a grape becomes a raisin, you know, you see this skin wrinkle on a planet. You have these fractures that occur, and these are the lobate scarps. Now, once again, Mercury is almost perfectly aligned, so the poles are perpendicular to the sunlight. This means that the North and South Pole, there are craters there that actually are always in shadow. They never receive sunlight. And the most bizarre thing about this is, even though Mercury is so close to the sun, it's either very hot on the surface or very cold. Mercury has both some of the hottest surfaces and coldest surfaces in the solar system. When the sun is up, it is hot. When the sun goes down, well, all you have is space. Everything radiates thermally into space, and the surface gets very cold. Well, in these craters, using the Arecibo telescope located in Puerto Rico, we see very strong reflections, which are indicative of ice being at the bottom of these craters. Basically, with radar is very useful in weather because it bounces off of water and it bounces off of snow. Well, by using this beam of microwaves from this large radio telescope, we can create pictures of the surface of Mercury. And in this case, we created a picture of the bottoms of the craters, and because they're highly reflective, we're pretty sure that that's probably ice. Now, in terms of the interior of Mercury, we originally thought that Mercury was just one solid object. You know, it had a core, it had a mantle, it had a crust, but all of them had solidified. Because Mercury being very small, would have radiated a lot of its interior heat rapidly and would have cooled much faster than the other planets. But instead, we now think, because Mercury has a weak magnetic field, that at least a small part of the core, the outer core, is partially molten. So with Mercury, it looks a lot like the interior of the Earth, except for its core is sort of supersized. It's got a very large inner core, which is solid like the Earth's inner core. It has a surrounding outer core, which is at least partially molten, we think, and then a thin mantle covered by a very, very thin crust. So the interior of Mercury looks a lot like our own planet, just that the core is much, much larger in proportion to the rest of the planet. Even though the core is about 45% of the total volume of the planet, takes up most of the radius, because Mercury is so much heavier than rock, most of Mercury's mass actually comes from the metal core. It makes up about 2/3 to about 3/4 of the total mass. And again, why does it have such a big core? Why is the core so large compared to some of the other cores? Well, one possibility, and this is just speculation, is that the core was created by a very violent collision with a large planetesimal. This was even before Caloris Basin formed. Caloris Basin was formed by a fairly large impactor hitting the planet. This event may have been between two, large protoplanets, the one protoplanet that became Mercury and another one that slammed into it. And when the two collided, most of the outer layers were vaporized. And because it was so close to the sun, unlike what happened with the Earth, where the Earth coalesced and the mantle was restored, most of the mantle just was blown away into space. So again, Mercury does have a magnetic field. We do think it's due to this outer core, but Mercury's magnetic field is only about 1% of the strength of the Earth's magnetic field. With all the planets, at least the inner planets, the interior of the planets are heated. They were heated originally by gravitational energy. Basically, as matter fell into the planet, the energy, the mechanical energy that they had was turned into heat. But it's been 5 billion years since the solar system formed. So a lot of this original heat is mostly radiated into space, especially for Mercury. However, there's still thought to be enough radioisotopes, uranium, thorium, potassium, that's decaying radioactively to keep the core very hot. And again, the mantle composition is similar to the composition that we see on Earth. Again, Mercury has an iron core, but the mantle rock is also rich in iron and magnesium. With many of the inner planets, the mantle material, the olivine, the pyroxene, these tend to have some silica in them, but it's usually a combination of iron silicate and magnesium silicate. That's what olivine and pyroxene are. And also some other materials, garnet and spinel. So the mantle is heavier than the crust. The crust and the mantle are thought to be solid, so there's no plate tectonics. We do see some ancient volcanism, and there's even some signs from the recent MESSENGER probe that some of the volcanism may be more recent. There may be very, very infrequent volcanic activity, but certainly it's not anywhere near the scale of what we see on Venus and on the Earth. Here's another indication that volcanic activity may still be going on in a very limited capacity on Mercury. This kidney-shaped object, which the yellow arrow is pointing to, shows a collapsed channel within a crater floor. almost as if magma had pooled in the bottom of the crater, and then the surface had hardened, and then the magma drained back out, leaving a void. There are also some interesting spider patterns that we don't see on the other terrestrial planets. This one's near a crater, but we still haven't really figured out what this is, although it does seem to have a similar pattern to what we sometimes see on Mars. So, Mercury, smallest of the planets, very dense core, no atmosphere, ancient surface. It is important to say that a lot of the information that we're getting from Mercury now, and this is from the Messenger space probe, is starting to have us question what we originally thought about this planet. Mercury is not a planet that we've studied very much. Up until the recent visit of the Messenger space probe, we've only had one spacecraft go by it, and it just went by it on a flyby mission. So, again, we're for the first time really getting a chance to study this planet close up. Now, Mariner 10 was the first space probe to visit Mercury. It visited when the technology of these space probes were not very sophisticated back in the 70s. And Mariner 10 made 3 flybys. They were very quick. The problem was they always looked at the same part of the planet, but obtained really the first detailed photographs taken of the planet, but only was able to map about 40%. It wasn't until the Messenger space probe that we really got a chance to study Mercury for a long time. It actually did a few flybys before it took up permanent orbit, and is now, in orbit around the planet and giving us the highest resolution photographs we've ever had. So, in the next few years, I think we're really going to start answering some important questions about the planet, such as why is it so dense? Why does it have such a big core? Maybe Messenger will give us some information showing us that, giving us proof that an ancient impact did create the dense core. What is the geological history? Mercury has a very ancient surface, but it also has a magnetic field, indicating that the interior might be partially molten. Does this also mean that volcanism is still happening? What is the state and structure of the core? Is the outer core really still liquid? And we can find out a lot about that by orbiting very close, but also studying the magnetic field. Again, if it does have a liquid outer core, then the process that produces the core is very similar to that we have on Earth. It could arise from some other process that we're not aware of. And again, what is the unusual material at the poles? The Arecibo studies seem to indicate that this is perhaps ice. Is it ice? Is it something else? So again, hopefully Messenger will answer some of these questions. It was launched in 2004. It actually had a very interesting trip. It had to fly past Venus a few times and past the Earth a few times to get a gravitational boost. And eventually, it did make it to Mercury. It flew by it twice in 2008, once in 2009, and finally took up permanent orbit in 2011. So it's been there for almost 2 years now, and we're just starting to understand some of the data that we're getting from it. And here's a complete trip. As you can see, it was launched from the Earth. It did a flyby of the Earth. It went past Venus twice, did 3 flyby missions of Mercury, and then finally took a permanent orbit in 2011. And that was all to save fuel. Messenger has discovered some water vapor in the atmospheric tail. We don't know what this means. Maybe this water vapor came from meteors that hit the surface or meteoroids that hit the surface. Maybe it's being given off by some small volcanic process. We're really not sure. Again, Messenger seems to have discovered some evidence for volcanism. This heart-shaped caldera clearly has some material which has been sprayed around it, which would be, sort of agreeing with the idea of some type of volcanic activity. Now, there is another mission planned for Mercury besides Messenger, and this is Bepi-Colombo. This would be the 3rd planned mission to Mercury. Both Mariner 10 and Messenger were missions from the United States. This would be a European mission, which is not scheduled to be launched until 2014 and wouldn't reach the plan until 2020. This was originally supposed to be a 5-component mission, where one of the components would have actually landed on the planet, but now they've reduced it to a 3-component mission, which would have 3 different orbiting spacecraft. So again, in summary, Mercury is the closest planet to the Sun. It's also the smallest. It has a highly eccentric orbit, and that just means that it goes around the Sun in more of an ellipse than really a circle like most of the other planets. All the planets are elliptical to some extent. They're not perfect circles, but Mercury would be the least perfect of all the circles. Mercury's mass is mainly made up of iron. It has the largest core in proportion, by proportion of any of the planets. Its surface is very old, highly cratered, and most of the surface seems to date back to the time that the solar system was forming, and the surface of the planets were being hit by massive planetesimals and asteroids. And last, Mercury has no significant atmosphere. That's why it looks like the Moon. Both Mercury and the Moon are too low in terms of the gravitational field to hold on to an atmosphere. Finally, only Mariner 10 and Messenger have ever visited Mercury. Okay, well, thank you very much, and that concludes today's chat.